Today we'll discuss ISI QROR 2023 paper, and the first question is, we are given this quadratic equation, and for this we can write sum of roots as -3 and product of roots as 1. Now we need to find alpha cube upon beta cube plus beta cube upon alpha cube. So what we'll do is, we'll rather find alpha upon beta plus beta upon alpha whole cube, and there will be alpha cube upon beta cube plus beta cube upon alpha cube plus 3 alpha beta, and that will be 1 into alpha plus beta, which is alpha upon beta plus beta upon alpha. So in order to solve this, we need to find alpha upon beta plus beta upon alpha, and that will be alpha square plus beta square upon alpha beta, which actually is alpha plus beta whole square minus 2 alpha beta upon alpha beta. Now alpha plus beta is -3 and alpha into beta is 1. So this value will be 7. So now we can write this as 7 cube, and this we need to find out alpha cube upon beta cube plus beta cube upon alpha cube plus 3 into 7, and if we rearrange, we'll get alpha cube upon beta cube plus beta cube upon alpha cube as 7 to the power 3 minus 21, and that'll be 322, and that's your option D. Now in question number 2, we are given that omega is non-real cube root of unity. We need to find the value of this summation. N varies from -50 to +50 omega to the power n. Now one thing that we know is, if omega is cube root of unity, then sum of any 3 consecutive powers, omega n, omega to the power n plus 1 and omega to the power n plus 2, will always be 0. First we'll count number of terms in this. So we'll have numbers from -50 to 0 and then up to 50. So there will be 50, 50 and 1. 101 numbers. So what we'll do is, in order to make terms which are multiple of 3, we'll add omega to the power 102 and we'll subtract omega to the power 102. Now here we have 102 terms with consecutive powers. So their sum will be 0. And now what's left is omega to the power 102. Now 102 is a multiple of 3 and omega cube is 1. So this value will be -1. So answer to this question will be this option A. Now in question number 3, we need to find sine 10 degrees is the root of which of the following equations. Now we know that sine 30 degrees is 3 sine 10 degrees minus 4 sine cube 10 degrees. Now sine 30 is 1 by 2 and sine 10 is this root, so we'll take sine 10 as x, so it will be this 3x minus 4x cube, which is actually 8x cube minus 6x plus 1 equals 0, and that's your option B. Now in question number 4, we are given this set. It says, for which of the following values of L will the set 1, 2 up to L will form a group under multiplication modulo L plus 1. Now the theory behind it is, if we have a set from 1 to p minus 1, then L form a group under multiplication modulo if p is prime. So this p, it has to be a prime number. Now in this case, rather than taking it as p, they have taken it as L plus 1. So we have to find the value of L so that L plus 1 is a prime number. Now 7 plus 1, 8, 15, 22. The only prime value possible is when the value of L is 28. In that case, L plus 1 will be 29. So answer to this question is this option D. Now in question number 5, we are given this matrix and it says it has 1 as an eigenvalue, then the determinant of A is. Now this determinant should have 2 eigenvalues. So let the other eigenvalue be x. So now we have 2 eigenvalues, 1 and x. Now we know that sum of eigenvalues is equal to trace of this matrix. So we can write 1 plus x equals a plus 3 or a equals x minus 2, and that's our first equation. And what we also know is determinant of A is equal to product of eigenvalues. So if we find determinant of A, that will be 3A minus 2 and AB equal to x. Now what we'll do is we'll substitute the value of A because we need to find x. So this is 3x minus 2 minus 2, and this is equal to x, which is 2x equals 8, or value of x equals 4. So value of the determinant for this matrix is 4, and that's your option C. Now in question number 6, we have to find the value of this limit. So what we'll do is we'll rationalize it. So now it'll be x plus 8 minus 8x plus 1, and here will be 5 minus x minus 7x minus 3 into, and this is under root of 5 minus x plus under root of 7x minus 3 divided by under root of x plus 8 minus under root of 8x plus 1. Now we can write this as this limit x tends to 1. Now here will be this 7 into 1 minus x, and in the denominator it will be 8 into 1 minus x, and here we put x as 1, it will be under root 4 plus under root 4. That will be simply 4, and here will be this plus sign, and here will be this under root 9 plus under root 9, and that will be 6. Now this 1 minus x will cancel. Now this is 2. So value of this limit will be 7 by 12, and that's your option C. Now in question number 7 it says, let Px be this polynomial where A, B, C are drawn uniformly at random with replacement from this set. What is the probability that polynomial Px has 2 distinct real roots? For each of A, B and C, we have 3 choices. So total number of polynomials that can be formed, it is given by 3 into 3 into 3, and that is 27. Now we need to find the condition that it has 2 distinct real roots. Now it can only have 2 distinct real roots if A is unequal to 0. So that means this A, it is unequal to 0. So now the choices that we have is either A is 1 or the value of A is 2. Now if A is 1, we can write its discriminant as B square minus 4C, and it should be greater than 0. That is B square should be greater than 4C. Now if we take C as 0, B should be greater than 0. In that case, B will have 2 values, 1 or 2. If we choose C as 1, then B square will be greater than 4. That is, B should be greater than 2, which is not possible. And for C equals 2 also, it is not possible. And if we take A as 2, we'll get D as B square minus 8C greater than 0, or B square is greater than 8C. Again here, if we take C as 0, we can take B as 1, 2. If C is 1 or 2, in that case, B has to be greater than 2, which is not possible. So these are the only 4 favorable possible cases. So in this case, this required probability will be 4 by 27, and that's your option B. Now in question number 8, it has asked for the coefficient of a to the power 6, b to the power 4, c square in the expansion of this product. Now we have AC plus BD to the power 6, and this is 1 plus A upon D to the power 8. Now if we write general term for this, it will be 6CR AC to the power 6 minus R BD to the power R, and here will be, suppose, 8CK 1 to the power 8 minus K, and this is A upon D to the power K, which we can write as 6CR into 8CK. Now if we take powers of A together, it will be A to the power 6 minus R plus K, then it will be B to the power R, C to the power 6 minus R, and d to the power r minus k. Now power of a is 6. That means we'll get r equals k. Power of b is 4. That means r equals 4 and k equals 4. If we put r as 4, we'll get c square and here will be 0. So this is what we are looking for. So its coefficient will be 6c4 into 8c4, which is factorial 6, factorial 4, factorial 2, and this is factorial 8, factorial 4, factorial 4. We need the result in terms of factorial 4. So what we do is we multiply and divide everything with 12. So 12 into factorial 2 is factorial 4. So we can write this as 12 into factorial 6 into factorial 8 divided by factorial 4 to the power 4, and that's your option A. Now question number 9 is a very standard theory question. We are given function f and then they have defined function for this set A and f inverse for this set A, and f inverse basically are images and pre-images of these set. Now we need to consider the following statement. Now this first statement is obviously false because we know that generally f x intersection y, it is a subset of fx intersection fy, and we get this equality sign when this function f is an injective function. So that means this statement 1 is not always necessarily true. And f inverse, we know that f inverse preserves all the property of union intersection. So this statement 2, it is correct. So answer to this question is statement 2 is always true and statement 1 need not be true, and that's your option C. Now question number 10 is a theoretical question. It says let G be a cyclic group of order 2023, the number of subgroups of G including the trivial and the whole group. Now we know that number of subgroups of G is given by number of divisors of 2023. Now we can write 2023 as 7 into 17 square. So number of divisors is given by 1 plus 1 into 2 plus 1, that is 6. So answer to this question is this option C. Now in question number 11 it says sum of all 3-digit positive numbers which are divisible by 7 but not by 14. Now the smallest 3-digit number which is divisible by 7 is 105, and then we have to find all the numbers which are divisible by 7 but not by 14. So it will form an AP with common difference 14. So next term will be 119 and it will go all the way up to, and what is the highest 3-digit number which is divisible by 7 but not by 14? 987. Now we have to find sum of this AP, and for that we'll have to first find number of terms. So it will be this 987 and will be equal to 105 plus n minus 1 into d. So here value of n will be 64. Now sum of n terms is 64 by 2 and this is 105 plus 987 and will be 64 into 546, and that's your option C. Now in question number 12 we are given this n which has 9 A's, then B, C and D. It's a 12-digit number divisible by 45. Now number is divisible by 45 if it is divisible by 5 and also by 9. Now divisibility by 5 is last digit has to be either 0 or 5, and divisible by 9 is sum of all the digits must be a multiple of 9. So if we write sum of all the digits, it will be 9A plus B plus C plus D, and it should be a multiple of 9. Now 9A is already a multiple of 9, that means B plus C plus D, it should be sum 9K. Now we know that D can only take two values, either 0 or 5, because this number, it has to be divisible by 5 also. So this case 1 is when D is 0, and this second case is when D is 5. Now if D is 0, we can write B plus C it should be equal to 9k. Now here a can take any value from 1 to 9. So number of choices for a is simply 9 for both the cases. Now if we look at this equation, then we'll have three cases, either b plus c is 0, or b plus c is 9, or b plus c is 18. Now here we'll have just one case, both of them they are 0. B plus c 9, here we'll have 0, 9, 1, 8 up to 9, 0, and that'll be total 10 cases. And here we'll have again one case, 9, 9. So altogether there'll be 12 cases. So in this first case, total number of such numbers will be 9 into 12, and it will be 108. Now for the second one, when d is 5, we can write b plus c as 9k minus 5. Now if we put k as 1, we'll get our first equation, b plus c equals 4. And if we take k as 2, 18 minus 5, it'll be 13. Now in this first one, we'll have 0, 4, 1, 3 up to 4, 0. So total 5 choices, and 13 is 6, 7, 7, 6, 8, 5, 5, 8, 9, 4 and 4, 9, and there'll be 6 cases. So in this case, we'll have 9 into 11 numbers, and there'll be 99 numbers. So total number of such numbers will be 108 plus 99, and there'll be 207, and that's your option C. Now question number 13, we are given a 4x4 upper triangular matrix with diagonal entries as -1, 1, 1 by 2 and -1 by 2. Then we need to find A inverse. Now if we look at this matrix, and suppose this is A, so it will be this -1, 1, 1 by 2 and -1 by 2, and then we have entries in the upper triangle. Here everything else will be 0. Now what we'll do is we'll find characteristic equation for this matrix. So we'll find determinant of A minus Ix. So it will be this determinant of -1 minus x, 1 minus x, 1 by 2 minus x, and -1 by 2 minus x, all these entries, and then we have all these zeros. Now we expand this determinant about this first column. We know value of this determinant will be -1 minus x into 1 minus x, 1 by 2 minus x, and -1 by 2 minus x, and it should be equal to 0 for characteristic equation. Now this is x square minus 1, and this is x square minus 1 by 4 equals 0, or x square minus 1 into 4x square minus 1 equals 0. So our characteristic equation will be 4x to the power 4 minus 5x square plus 1 equals 0. So this matrix A will satisfy this equation, 4a to the power 4 minus 5a square plus I equals 0. Now we'll multiply everything with A inverse. Then we'll have 4a cubed minus 5a plus A inverse equals 0, or simply A inverse is 5a minus 4a cubed, and that's your option D. Now in question number 14, we are given this second order differential equation. Now we can write this equation as d square plus 2d plus 1y equals 0. So d plus 1 whole square equals 0. So d is -1 minus 1. So we have two equal roots. So its solution will be y equals a plus bx into e to the power minus x. Now we are given that when y is 0, x is 0. So when y is 0, x is 0. So that means value of a is 0. So now we have y equals b x into e to the power minus x. Now it says when x is 0, y dash is 1. So this y dash is b minus x e to the power minus x plus e to the power minus x. Now this is 1 when x is 0. So that means value of b is 1. So this y will be simply x into e to the power minus x. Now what it has asked for is value of y when the value of x is 1. Now if you put x as 1, we get y as e to the power minus 1, and that's your option A. Now in question number 15, we are given dy by dx and d2y upon dx square. We need to find d square x upon dy square. Now we know that dx upon dy, it is 1 upon dy by dx. Now what we'll do is, we'll differentiate everything with respect to y. So we can write d square x upon dy square, and it will be minus 1 upon dy by dx whole square into d by dy of dy by dx. Now what we'll do is, we'll write this as dy by dx into dx. So we can write this as minus 1 upon dy by dx whole square into d by dx of dy by dx, and we'll also have this one more dy by dx. So it will be minus d2y upon dx square divided by dy by dx whole cube. Now this is gx and dy by dx is fx. So it will be minus gx upon fx cube, and that will be your option B. Now in question number 16, we have to find value of this integral, which is this integral from a to a plus 1 greatest integer function of x dx. Now if we draw this graph, now suppose this is a and this is a plus 1. Here this value will be greatest function of a plus 1. Now in this interval, it will take some value. Now here this value will be greatest function of a, and here this value will be greatest function of a plus 1. Now we need to find this integral, which actually is this area. So we can write this as greatest function of a into, and this is greater function of a plus 1 minus a, and plus here will be greater function of a plus 1, and here will be this a plus 1 minus greater function of a plus 1. So there will be a minus greatest into function of a. Now here we will take these two together. So we can write greater function of a plus 1, and then will be greatest into function of a plus a minus greater function of a, and minus a into greater function of a. Now this greater function of a will cancel. So we can have this as a into greater function of a plus a minus a into greatest function of a. So it will cancel, and this value will be equal to a, and that's your option B. Now in question number 17, we are given this matrix, and it says rank of this matrix depends or is independent of A or B. So what you're going to write is, we're going to write this matrix. First row is 0, 1, 0, 0, and 0. Now for the second row, we can eliminate this one using row operations. So it will be this 0, 0, and we'll divide everything with 2. So it will be 1, 0, 0. Now for this third row, we'll divide this third row by 3, which again is an elementary row operation. Now for fourth row, we can eliminate this one. We'll have 0, 0, 0, A0, and we'll divide everything with A. So we can write 0, 0, 0, 1, 0, and here will be 1, 0, 0, 0, B. Now these two rows, they are same. So we can again make this 0. So rank of this matrix will be 4, and it doesn't depend on A. And whatever value of B we are going to take, this matrix will always have a 4 cross 4 submatrix which is non-zero. So its rank will always be 4 irrespective of value of B. So rank of this matrix is independent of values of both A and B, and that's your option B. Now in question number 18, we are given that ABC are sides of a triangle such that C square equals A square plus B square minus AB. Now we can rearrange this as A square plus B square minus C square equals AB, or A square plus B square minus C square upon 2AB equals 1 by 2. Now this is nothing but cos C. So this cos C is 1 by 2. That means this angle C is 60 degrees. Now if angle C is 60, then either all the three angles, they are same, they are 60 degrees. And we know that A plus B, it is 120. Or this other case, when one of the angle is less than 60 and the other angle is greater than 60. So it will be either A is less than C is less than B, or B is less than C is less than A. So generally we can write either A is less than equal to C is less than equal to B, which will give us A less than equal to C less than equal to B, or B is less than equal to C less than equal to A, from where we get B is less than equal to C less than equal to A using sign rule. That means the correct option is this option C. Now in question number 19, we are given this circle whose center is at 2, 3 and this radius will be 4 plus 9 plus 12, 5. So we'll have this circle having center at 2, 3 and radius 5. Now it says there are 2 points on the circle where we have drawn the tangents. So at 2 points, we have drawn the tangents and the 2 points are B and D, and this point is A. Radius is 5 and this point is C. We have to find area of this quadrilateral. For this we have to find length of BC, and for that we have to find this C. Now we are given this point D, it is 2, 8 and D is 5, minus 1. Now we know that if point lies on the curve, then equation of tangent is given by T equals 0. So we can write T equals 0 as 2x plus 8y minus 4 x plus 2 by 2 minus 6 y plus 8 by 2 minus 12 equals 0. Now this is 2 and here this is 3. Now 2x and 2x will cancel. So we'll get 5y and here will be minus 4, minus 24, minus 28, minus 12, minus 40 equals 0. We'll get value of y as 8. So y coordinate of C is 8. In the same way, we can write equation of tangent for D again using T equals 0. Now it will be 5x minus y minus 4 x plus 5 by 2 minus 6 y minus 1 by 2 minus 12 equals 0. Now again here this is 2 and this is 3. So we get 5x minus 2x, 3x minus y minus 3y minus 4y. This is minus 10 minus 12 minus 22 plus 3 minus 19 equals 0. Now we'll put y is 8. So there will be 32 minus 19, 51. 51 divided by 3 is 17. So x coordinate will be 17. So this C is 17, 8. Now we find this distance BC. This distance will be actually 15. Now area of quadrilateral is R into this distance. So it will be this 5 into 15, 75. And that's your option B. Now in question number 20, we are given this triangular park with coordinates 0, 0, 4, 0 and 1, 4. A pavement of uniform width 1 unit has to be built all around the park as shown in the figure. What is the total area of the pavement? Now first we'll calculate length of the 3 sides. Now this is 0, 0, this is 4, 0. So this length is 4. Now this is 1, 4, 4, 0. So that will be under root of 3 square plus 4 square. So it will be 5, and here will be under root of 1 square plus 4 square, and that will be under root 17. Now these three portions, they're easy to calculate. For each of them, width is 1 unit and lengths are 4, 5 and 17. So this area will be 4 plus 5 plus under root 17. Now what we are left with is these three circular areas. Now this is 90, this is 90, this angle is B. So this angle will be pi minus B. In the same way, it is pi minus A, and here will be this pi minus C. So sum of all the three angles will be 3 pi minus A plus B plus C, which is 2 pi. So actually all these three portions, they'll form a circle whose radius is 1, and this required area will be simply pi and r, which is 1. So this area will be 9 plus root 17 plus pi, and that will be your option. Question 21, it says P is a real polynomial of degree 5 such that equation has exactly 4 distinct real roots. Now any real polynomial cannot have 4 distinct real roots. So basically there has to be one equal root. So we can draw this as 1, 2, 3 and 4. Suppose like this. And the roots are alpha 1, alpha 2, alpha 3 and alpha 4. Now it says this equation P dash x equals 0 has how many roots? Now this function, its derivative will be 0 at this point, at this point, at this point and at this point. So P dash x will be 0 at 4 points, and one of those points will be any one of alpha 1, alpha 2, alpha 3 and alpha 4. So answer to this question is this P dash x will have exactly 4 distinct real solutions, and exactly one of them will belong to this set containing alpha 1, alpha 2, alpha 3 and alpha 4. So answer to this question is this option B. Now in question number 22, we are given this series fx, which is this summation n varies from 1 to infinite minus 1 to the power rn sine nx upon n square. Now what we will do is we will consider two series. This an, it is minus 1 to the power rn sine nx, and bn is 1 upon n square. Now we know that 1 upon n square, it is 1 upon n to the power p series where p is greater than 1. So this series, it converges, and this an, which is minus 1 to the power rn sine nx, depending on the value of r, it may alternate or it may be positive also, but then this series, it is bounded. And further we can write minus 1 to the power rn sine nx upon n square will be less than or equal to 1 upon n square, which is a stronger convergence. So that means this fx is going to converge for every x belongs to r and every integer r, and that's your option A. Now in question number 23, we have to find the value of n so that n is an integer. Now here we have under root of mod a minus 3 and under root of 3 minus mod a. So domain of this function is mod a minus 3 is greater than or equal to 0, and 3 minus mod a is also greater than or equal to 0, and denominator is unequal to 0. So that means a is unequal to 3 and a is also unequal to minus 4. Now from here we can write a is greater than or equal to 3 and mod a is less than or equal to 3. Now it is only possible when mod of a is 3, that is value of a is either 3 or a is minus 3. Now a cannot be 3, so the only condition we have here is value of a should be minus 3. And we put value of a, we can write n as 1 plus 6 upon 1 minus 0. So value of n will be 7. And that's your option C. Now in question number 24, we are given f1x, which is ax plus b. Now f2x will be a ax plus b into b. So there will be a square x plus b 1 plus a. Now f3x will be a cube x plus b 1 plus a square. In the same way we can write f7x, and that will be a to the power 7x plus b into 1 plus a up to a to the power 6, or we can also write this as a to the power 7x plus b a to the power 7 minus 1 upon a minus 1. Now we are given that it is equal to 128x plus 381. Now we compare a to the power 7 with 128, we'll get value of a as 2, and if we put a as 2 here, we'll get b, and this is 127 and will be equal to 381. So value of b will be 3. Now we need to find the value of a to the power b, which is 2 cube, and that will be simply 8, and that's your option C. Now there is a box containing balls numbered a plus 1 up to 500, where a is less than 500. Now suppose that for each x, the probability that the ball numbered x is picked is xa divided by 500 plus a into 500 minus a plus 1, then the value of a is. Now we know that the event the ball number x is picked, it is mutually exclusive and exhaustive. Then in that case, sum of all probabilities, it must be equal to 1. So that means this summation xa upon 500 plus a, 500 minus a plus 1, it should be equal to 1. Now we can take a upon 500 plus a, 500 minus a plus 1 out, and then it will be simply this summation x, and it is equal to 1. Now what is summation x? It is a plus 1 up to 500, which is an AP with common difference 1. Now number of terms in an AP will be 500 minus a plus 1. So it will be this a and then n by 2. So it will be 500 minus a plus 1 by 2, and then a plus l, a plus 500 divided by 500 plus a, 500 minus a plus 1, and it will be equal to 1. Now both of them will cancel. So value of a here will be 2. So answer to this question is this option B. Now question number 26 is a standard question. We have defined this function in terms of rational and irrational. We know that such functions, they are continuous only at points where f1x equals f2x. So they'll be continuous at points where x square is equal to 3x minus 2 or x square minus 3x plus 2 equals to 0. So this fx will be continuous only at x equal to 1 and x equal to 2. And that's your option D. Now question number 27. It says we are given two functions fx and gx. Fx is x when x lies between 0 and 1. Gx is 1 when x lies between 0 and 1. It says T denotes the triangle in the real plane bounded by x-axis, y-axis, and this line which is x plus y equals 2. Now this point 1 common will lie here. Now this square where value of x lying between 0 and value of y lying between 0 and 1 will lie inside this triangle. We have to find this integral fx gy dx dy, and we can write this as this integral from 0 to 1 and then this integral from 0 to 1. Now in 0 to 1 fx is simply x and gy is simply 1, and that will be dx into dy. So we can write this as 0 to 1 x dx, and then it will be 0 to 1 dy, which is x square by 2, and that will be 1 by 2. So answer to this question is this option B. Now in question number 28, we are given this complex number z such that mod of z equals 1. So let z be a plus iota b, and we know that a square plus b square, it is equal to 1, or we can write a as plus minus under root of 1 minus b square, and imaginary part is rational. So this d, it belongs to q. Now it says, then which of the following is necessarily true? Imaginary part or real part of z to the power n. Now what we do is we look at a plus iota b to the power n. Now this is nc0 a to the power n minus nc1 a to the power n minus 1 iota b plus nc2 a to the power n minus 2, and then it'll be this minus b square. If we look at real part of a plus iota b to the power n, it'll be a to the power n minus nc2 a to the power n minus 2 b square. Now if n is even, then it'll be a square to the power n by 2, and a square will be 1 minus b square, which is irrational. So in this case, this real part will always be a rational number. And since we have taken n as 2 to the power n, it will always be even. So for this question, answer is this option B. For each n greater than or equal to 1, the real part of z to the power 2 to the power n is a rational number. And question number 29, we are given this set A, which has finite number of real numbers m elements. Then we have defined a function fx, which is minimum of mod a minus x. Now for this function, we have to choose minimum value of mod of a minus x depending on the values of a in this set. Now we know we solve such questions by drawing graphs. So suppose this is a1, a2 and am, and for this graph we have to choose the minimum element, and if we choose the minimum element, we'll always get a continuous function. So this function will always be continuous for all x belongs to R. So answer to this question is fx is continuous everywhere, and that's your option A. Now question number 30 is, what is the maximum value of this expression for x lying between 0 and 1 by 2? So this y is x minus x square upon 1 plus x. Now y dash will be 1 plus x, 1 minus 2x minus x minus x square upon 1 plus x. Now this is 1 and then minus x minus x. So there will be minus 2x square plus x square. So there will be minus x square upon 1 plus x whole square. Now if we put it equals to 0, we'll get critical points as x plus 1 whole square equals to, or x equals minus 1 plus minus root 2. Now we have to find maximum value in this interval. So we have three critical points. Either x is 0, x is 1 by 2, or x is minus 1 plus under root 2. Now if we put x as 0, we'll get y as 0. So this is one value. When x is 1 by 2, y is 1 by 2 minus 1 by 4, and this is 1 plus 1 by 2. Now this is 1 by 4, 1 by 2, so it will be 1 by 6, and if we put x as minus 1 plus root 2, we get y as minus 1 plus root 2 minus 1 plus root 2 whole square, 1 plus x, which is root 2. Now this is minus 1 and this is 3. So it will be 3 root 2 minus 4 upon root 2, or it will be 3 minus 2 root 2, which is the highest value among the three. So the maximum value of this expression is 3 minus 2 root 2, and that's your option C.
Hello and welcome to the world of mathematics. I present my website www.mathsmarazing.com and my YouTube channel Mathsmarazing for your kind perusal. If you like them and are inspired by the possibilities, then consider subscribing and sharing it with someone you know who might benefit from it. Thank you.